Good morning, everyone. Welcome to another lesson. This term, we are learning about energy. Have you ever played this game? It's called Four Pictures, One Word. And the thing is, you need to find what is connecting all four pictures. Now, the question is, what is the connection? Pause the video and give yourselves 5 minutes to complete this activity. If you cannot get the answer, feel free to involve anyone in your house, such as a parent, a caregiver, or a sibling. Give yourselves 5 minutes to complete this task. Welcome back. Did you get the answer? The answer is energy and energy stores. Congratulations if you got any one of the two answers given. You are a star. If you didn't, good try. Today's driving question is, what is energy and the different types of energy stores? So what does energy has to do with my dog running? Good question, Samantha. Let's have a look. Okay, this is both a simple and complex question. Energy is in everything. It is often described as the ability to do work. So where does this energy comes from? Aren't you full of questions today? Let me explain. Almost all food energy comes originally from sunlight. The chemical elements that make up the molecules of living things pass through food webs and are combined and recombined. At each link, some energy is stored, but much is lost along the way in the form of heat into the environment. So, in an essence, the main source of all energy is the sunlight. Take away the sun, everything stops. They have a saying that hell will freeze over, literally. You notice I said energy is stored, right? Yeah, let me expound. There are a few energy stores, such as one, chemical. This is energy stored in bonds of chemical compounds like atoms and molecules. This energy is released when a chemical reaction takes place. Kinetic, kinetic energy. This describes the energy an object has because it's moving. Gravitational potential. These energy stores are used to describe the energy stored in an object because of its unique position, such as above the ground. So, again, gravitational potential energy is used to describe the energy stored in an object because of its unique position, such as above the ground. Thermal. This is the energy associated with objects' temperature, which is due to the random motion of particles within an object. And last but not least, and again, last but not least, simply means that there are more, but I'm stopping at this for today. Elastic potential energy or elastic energy stores. Elastic potential energy store is stored as a result of the formation of an elastic object, such as the stretching of a spring. Again, elastic potential energy is a store that results from the deformation of an elastic object, such as the stretching of a spring. Now, I do recommend that if you did not readily get all of what was just read, I'm going to ask you to pause the video, go back, and start over again, because these definitions will be important for you as you move forward. Quick assessment, different energy stores. Now, I want you to pause the video and have a goal based on the definitions that were given on the previous slide. Match the images below to their energy store. A candle, a cheetah, rubber bands, food, and soldiers jumping. Give yourselves 5 minutes before going ahead. Welcome back. Now, chemical. Which one of these pictures would match chemical based on the definition given before? Chemical would be in the burger. Remember, all foods store chemical energy. Kinetic energy. Which one of these images or pictures would represent kinetic energy? Remember, kinetic energy is energy that an object has because it's moving. Gravitational potential. This one is kind of a giveaway. Gravity. Which one of these objects seems as if gravity is acting the most? The parachutes. These are soldiers who have jumped from a plane. Thermal. What does the word thermal sounds like? This is again another giveaway. The candle. And last but not least, elastic. Again, we all know what elastic makes reference to. Elastic bands. So therefore the rubber bands. Now, different energy stores and transfers. When you eat food, this is a chemical store. You transfer the energy into different stores. Kinetic energy stores when you move. Thermal stores to maintain your body temperature. Chemical stores when you make different compounds in your body. So, right? Take that in again. When you eat, this is a chemical store. Food stores chemical energy. Now, once this energy gets into your body, it is stored differently because of the different stores that we have inside our bodies. Now, kinetic stores when you move, when you run, when you walk, when you move. Thermal, your body temperature, to maintain your body temperature. Chemical stores, when you make different compounds in your body. Now we know 5 different energy stores. Energy can be transferred between stores as electric, light, sound, or mechanical when a force acts on an object. For example, a battery operated fan. The energy stores move from chemical to kinetic. Why is it moving from chemical to kinetic? Chemical, the batteries store chemical energy. Kinetic, what in this fan is moving? The blades, which produce wind. So again, chemical to kinetic. Chemical from the batteries, which operates the blades on the fan, which is kinetic. Energy is transferred as electrical energy. Now you are going to identify stores and energy transfer from this little activity. Identify the energy store at the beginning, the energy store at the end, the energy transfer, and record your results. Now looking at a candle, energy store at the start. All is the energy stored in the candle. At the end, if you lit the candle at the beginning, what kind of energy is given off? Last bit, what is the transfer? Same thing will be done for a battery operated torch and a air dryer. So again, lighting a candle, battery operated torch, and a hair dryer. You should give the energy store at the start, energy store at the end, and the energy transfer. Pause this video, give yourselves 5 minutes. Once you're finished, you need to continue with the video. Remember energy stores. There are a few energy stores, but it's not limited to just these. The ones that we looked at today is chemical, thermal, kinetic, gravitational potential, and elastic. Energy transfer includes electric, light, sound, and mechanical. A force is acting on the object. Now, I want you to pause the video. Yes, pause this video. Go over to Google Classroom, look for the other video, and play the video. From this video, I want you to identify the different energy stores found within this video. This video depicts Mr. Samuels going home after a long day at school. He carries out different activities at home, which involves different energy stores. Your job is to identify the different energy stores in the video. What you're going to do, you're going to list the stores, take a picture, and send them in. Now, the answer to the table before. So as you can see, energy, lighting a candle. Now your candle contains or store chemical energy. Energy stored at the end. Once you have lit the candle, all that chemical energy is transferred into thermal. You're feeling heat. And what is it that you get from the thermal energy released? You get light. The battery operated torch. Again, the batteries store chemical energy. What is given off from a torch? Thermal energy. And what you know torches are used to do? Give light. Hair dryer. At the beginning, the store. Chemical. Burning fuel at power station. At the end, kinetic energy. Why is it kinetic energy? Because it is blowing out hot air. Yeah. So the air particles going through the blow dryer, they are moving and they are hot. One thing we know hair dryers are good for is giving off sound. Now, the law of conservation of energy. What do you think this is? Share your idea with someone in your house. Do they have any different ideas? Do you want to change your ideas? Give yourself 5 minutes. The law of conservation of energy. What do you think this is? In pairs, come up with an explanation. Now your 2 minutes are up. Now, do you have different ideas? Do you want to change your explanation as to what the law of conservation of energy is? Now, the law of conservation of energy. Energy cannot be created or destroyed, but is transferred from one store to another. In all of the experiments, there was an energy store at the beginning and an energy store at the end. The only thing that changed was the amount of energy in the store. Again, energy cannot be created or destroyed, but it is transferred from one store to another. In all of the experiments, there was an energy store at the beginning and an energy store at the end. The only thing that changed was the amount of energy in the stores. Copy the title and law into your books or onto a piece of paper or take a picture of it. You will need to remember this for future lessons. Choose one of the experiments and explain how it reflects the law of conservation. Experiments are the ones that we looked at using the flashlight, the candle, and the hair dryer. Now, I want to give a big shout out to Twinkle for providing the foundation for our lesson today. Assessment. What is the main energy transfer taking place in a solar-powered calculator? What are the energy stores involved when using camping stoves? Last, what are the energy stores and pathways involved when turning on an electric radio? Now, I want you guys to try to answer these questions. Take a picture of them and send them in to Google Classroom. Until next time, I am your teacher. See you on Wednesday for another exciting lesson.